Whoa, that was some weekend. Well, we're back. It's Monday, Bellringer fans, and across the world. Good to see you back here in room H212, Mr. Kovacs' room, for this day's first Bellringer of the week. And remember, we're counting down the top 10 best things that we've learned this year. Today, we're on number 9. Number 9, 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 number 9. Da 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 do 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 do. Da 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 do do. All right. Da 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 do do do. Hey now. Da 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 do do. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class. Number 9 on the countdown. Brains. Brains. Yeah, we learned about brains. We dissected brains. We talked all about brains. Brains, of course, brains are part of the nervous system, right? They're kind of the big cheese, the boss of the nervous system. Brains. See what you remember about brains and neurons and nerves and all that stuff. Yeah, brains. They're made up of neurons. Neurons are the unit of nervous tissue, right? A neuron. Bundles of neurons together are called nerves. Neurons. And neurons, of course, have this kind of interesting build. They're long, skinny cells with dendrites at the front, this long axon, and then the axon terminus at the end. And if you remember, in order for a neuron to do its thing, it has to be switched on by a neurotransmitter, right? So that neurotransmitter binds to receptors in the dendrite, and if they reach what we call the action potential, an electric signal will be sent down from one end of the nerve cell to the other end of the neuron, and then more neurotransmitter will be released into the synapse between those two cells. Right, the movement of that electrical signal down the length of the axon is called the action potential. The action potential. Right, when the action potential reaches the terminus of the axon, it stimulates neurotransmitter to be released. Action potential comes down the neuron to the axon terminus, where then it releases neurotransmitter into the synapse. And if those neurotransmitters bind to the next cell, it starts a new action potential. Talked a little bit about how pharmaceuticals work. Pharmaceutical drugs usually work in the synapse. They can do one of two things. They can stimulate the cell to release more neurotransmitter. They can block the receptor proteins in the cell membrane of the postsynaptic cell, or they can block the reuptake of neurotransmitter in the presynaptic cell. All of those things cause changes in the way nerve cells communicate to each other, which can do a lot of things, right? Like, imagine if you're sending pain signals, you want the pain to stop, you can block the pain receptors, right? If you block those pain receptors, you're not gonna be able to turn on the next nerve cell, and your pain is going to stop. That's how pharmaceuticals work. All drugs work. Of course, the brain is really nothing more than a bunch of neurons connected to each other and constantly shape-shifting, growing, making new connections with new neurons. We call that learning, right? And we've learned that the different parts of the brain have different. The frontal lobe of the brain is where most of your memories and thinking are, right? Whereas like the occipital lobe in the back of your brain processes vision. The parietal lobe is like coordinating muscle movements, whereas the temporal lobe, auditory information is received by the temporal lobe. And down here, of course, the brain stem, number 4 on this picture, does all the kind of life basic stuff, like reminding you to heart to beat and breathe and things like that, and go to sleep and those kind of things. And 3 here, the cerebellum kind of coordinates you in space, keeps you balanced in space. So it's whole brain together works. What we talked about with the brain that was weird is if you do brain surgery, right? If you do surgery on the brain surgery, there's no pain receptors in the brain. So you can do brain surgery while the patient's wide awake, right? Which is really weird. Like this guy right here playing guitar while they're doing work on his brain. That's just kind of weird. That's right. Today, number 9 on our list. Number nine. Brains. What do you think number 8 will be? Stay tuned.